Good morning and welcome to Race Industry Now, the weekly webinar series from ePartrade, presented to you by ARP, Performance Plus Global Logistics, PIC, Shop Monkey, and Fifth Third Bank Motorsports. I am Francisco Savignan, the founder and CEO of ePartrade, the global platform for the performance and racing industry. This is episode 340, and we're going to be talking weight and engine performance with Fluidampr. With me this morning are Judy Kinn, the co-founder of ePartrade, and our superstar host back this week with us, Mr. Jeff Hammond. Judy?
Thank you, Francis. It's hard to believe we did announce that this month is our 5-year racing or anniversary. Hard to believe how much we've evolved in 5 years. 3 years ago, we actually started these webinars with the help of Jeff here and Brad Gilley. We have 5 great, deeply rooted racing sponsors on board, believing in this platform and what we're doing. And we're all very thankful to all the buyers and suppliers using this platform as like a trade show lead going through the system. So we're just extremely grateful to the industry, and we keep evolving, Jeff, don't we?
Oh, yes, you do. And again, it's been an honor and a pleasure to be associated with you folks and watch this rapid growth over the last 5 years and the way that the industry as a whole has embraced ePartrade, not only on a weekly basis, but, 365 days a year, which is the one thing that we bragged about early on in the very inception of this program, is that, you guys never really go to sleep. You give an opportunity where it's worldwide. And if you know how to work the platform, it's at your disposal. If you wake up at 2:30 in the morning, some people would like to say, like DW called me one morning and said, "Hey, I had a dream." I said, "Yeah, another guy did too, but not at this time of the morning." But it works perfectly for those who can't sleep when they're worrying about something, because you've got a lot of the answers. And again, it's been a pleasure and a privilege to meet all the fine vendors and associates that go along with the industry over the last 5 years.
Thank you for your very nice words, Jeff. Yes. And so, we don't sleep. That's why I'm wearing glasses now. When we started, I did not need glasses. So we are going to bring our 2 guests, but before we bring them on, we have a special video to show you from Fluidampr. So let's roll the video, and during the video, we'll bring the speakers on.
Fluidampr Performance Dampers since 1985. Unleash the power and protect your engine. Engine builders, race teams, and performance enthusiasts seeking to maximize the potential of your engine, Fluidampr Performance Dampers are the ultimate solution to enhancing engine performance while safeguarding its longevity. Engineered with precision, built to deliver outstanding results, Fluidampr has revolutionized the world of performance dampers. Trusted by professionals, Fluidampr has earned a solid reputation among performance enthusiasts, professional racers, and engine builders worldwide. Our dampers have been rigorously tested in demanding conditions, and their performance has been proven on the street, the track, and in competitive motorsports. When you choose Fluidampr, you're choosing a product trusted by the experts. Unleash your engine's potential. Fluidampr performance dampers are meticulously designed to suppress harmful engine vibrations across a wide range of RPMs. By effectively managing torsional vibrations, you'll experience improved power delivery, enhanced throttle response, and increased overall performance. With Fluidampr, you'll feel the difference on the road or the track, unleashing your engine's true potential.
Thank you very much. And I think we've got Aaron here and with Nick. So we're going to ask Nick to start his video. And Jeff, you are in charge. Good morning, gentlemen.
Good morning.
And congratulations, Aaron just got married and is coming back from his honeymoon. Congratulations.
Thank you. No, it was a great time, but I'm ready to get back into working on some Fluidamprs for everybody out there who needs engine protection.
Well, again, I'd like to extend my own personal congratulations to you, sir. I think there's, I'm going to say you're a lucky man and she's a lucky lady, and I wish y'all very much a very happy life together. And again, welcome back to the grind, as they like to say. And Nick, I hope you're doing well today.
I am. Thank you for having us on.
No, we're excited about you being on, because I think the one thing that let's get rolling on this is that, you know, through your video, we're seeing not the old drag racers or the NASCAR guys. We're looking at a lot of, you know, new and exciting areas that motorsports is taking the industry. And, you know, how hard is it to keep up with what's coming down the line? Because it seems like, you know, instead of, you know, big blocks, we're going small block. We're going, you know, small cylinders, but yet a lot of RPM, a lot of torque. How does that affect? And let me just break it back down. Fluidampr as a whole, but just the challenges of controlling that energy that you're creating, that they're creating.
Yeah. So as you said, like motorsports has evolved and changed. You know, the diesel racing community is getting faster and more power, creating more torque, more heat, you know, the horsepower and all those levels. But not only that, you know, like drifting is an enormous community itself, and those guys pack in as much stuff as they can under the hood. So you're creating heat and everything. And Fluidampr has always been known for its robust steel design. We've been, you know, having a lot of advancements in material and processes, and as that technology grows, you know, we grow with it. So we've come up with some new. Aaron has come up with some new, really great designs to combat, you know, heat and weight and all those different aspects of it. So Aaron had put together a pretty great lineup, so I'll let him take off with that now.
Thank you, Nick. So one of the biggest things that we talked about, you know, and as Jeff mentioned, is that, you know, bucking the tradition of, you know, larger is better, you know, bigger is better, you know, jump into a big block, you know, with everything, you know, downsizing because of, you know, aero advantages, packaging, you know, getting your chassis tight, everything is tighter, everything's space is more limited. And you're expecting more and more out of a smaller package as far as horsepower and torque goes. You know, the same is true with the damper. And one of the biggest things that Nick mentioned, you know, going the jump from a steel damper to an aluminum damper, that also comes with a weight reduction. But it's not the whole damper weight that's coming down. It's the part of the damper that attaches to the crankshaft or attaches to a crank hub. And that's where traditionally, you know, we can remove some weight from that jumping to aluminum with, you know, so, you know, increases in technology advancement with welding processes. We're able to bring more robust designs for that. And then that's what helps increase the engine efficiency by taking some weight out of the rotating components without sacrificing engine protection. So we have parts that run that aluminum and then the normal single mass ring inside of it. And then from there, you know, we have a patent pending technology that I'll show you an animation for shortly here, where we take that internal ring and we step it up even further technology wise.
No, y'all touched on the fact about the heat. How much is that affecting your? I mean, we know you got silicone inside there, and you know it's got to have a limit on what it can stand within the engine compartment. And is that forcing you to change your stuff that you use, or are you having to create, a better silicone? Let's put it that way.
So the biggest thing with that is, the silicone fluid, you can get different levels of silicone fluid that are refined, that have a little bit have longer working life. But the silicone fluid itself is very similar to the technology that we've been using all along, but it's the application of that fluid that is actually what the technology advancements are really showing. And actually, if you don't mind, I'd like to share a couple of animations if I can share my screen. And
Please
I can
do.
kind of show you what we do to combat
This
that
show
heat.
is all about show and tell.
Okay. All right.
So
Well, here
also
goes.
on top of that, with what Aaron was saying, real quick, the silicone that we use is stable from -40 up to 300 degrees.
Yeah, that's the working range for indefinite life. We can work outside of that range with higher heat applications, but those are, like we do that a lot with endurance racing. And those applications, are more heavily monitored. So there is a way there, just have to work closely with us if you have a special application that's even hotter than that.
Okay.
So I'm going to share my first animation. So this first animation here is just going to basically show a single traditional layout of an aluminum damper. And as we cut away through it, this is the traditional, this is, as this rotates, you're seeing movement of this ring here. And this is what generates the heat, because that silicone fluid stabilizing between the two is what creates, the heat and pulls energy out of your system and reduces your crankshaft from twisting. So this second animation, what we're looking at here, we put, as we have a lot of heat generation starting to happen in the system. I'm going to restart that. So the same layout, same housing. So now we have a couple of different inertia rings in here. And as you can see, they're moving in and out of phase with each other even. So what this does is this gives you two separate vibration frequency bands that give you two different resonant rates, because the dampers work when that flywheel is moving in and out of phase. You get to see the damper is actually broadening its effective range, so you can tune those two different inertia rings for different frequency bands. So you'll get in a sense, you're going to get three different vibration optimum frequencies. One when the two rings are moving as one, like traditionally shown in the first animation. And then you get another one when one ring is moving independent of the other, and then when the other ring is moving independent, based on your engine RPM, and cylinder firing and different aspects of the engine. So this is a way to get more vibration control out of a smaller damper package and also helps keep weight down. We also have a similar layout that we do for high heat applications, where you have two identical twin flywheels within the same damper, and that actually will take your power generation and split it in half for high heat applications. And what that does is it gives you more heat transfer area, similar to adding more blades to a fan or more fins to a radiator, but you're actually splitting that power generation exactly in half. And then you can add things like cooling fins, aluminum housing, stuff like that. And that's something that we've been able to do for customers, not just in motorsports, but also in OEM high performance. Most recently, if you looked at a bunch of the press pictures for the D170 Challenger, and you can see a Fluidampr product prominently featured on that crankshaft. And that's a high heat and high power generation application with the twin flywheels.
Okay, I've been doing a little bit of reading about the function of a fluid dampener, and make sure I got what I just saw. Is it when all of this is working like it's supposed to, that creates the shear effect, and the shear is what helps to eliminate the unwanted vibration. Is that correct?
Yes. So the when the rings inside of the Fluidampr move, they'll move counteracting the vibration of the crankshaft. So
Okay.
the outer housing, as it's spinning, it's moving similar to like your steering wheel when you have a warped rotor. So your crankshaft's doing that while it's spinning. And if you had a really precise tack, you could actually watch the RPM needle change. But because we typically run lower resolution tacks, you want a nice stable RPM sweep in your gauges. But if you picked enough counts for that tack, you would actually see your RPM fluctuate as the engine's spinning. And so what the inertia ring is connected to the housing with by the silicone, and the silicone creates a weaker spring rate than your crankshaft. So when the crankshaft wants to twist, that ring will move instead of your crankshaft twisting, and then the heat is created by the silicone because it stabilizes the ring, so it only moves a very specific amount.
I mean, to me, I think that's, it's almost like mad scientist type stuff. You know what I'm saying? When all this is going on. And since we're in here all about the rings and the movements and everything, what challenges you the most? I mean, is it the quick acceleration or something that, that it's maybe more of a diesel type where it would be the torque effect? I mean, what gives the biggest challenge for you guys to deal with? Is that quick acceleration or the big, a steady torque pull type acceleration?
So I guess the biggest thing is the amount of the event that moves the flywheel and then where it's happening. So the number of times it happens per second when we talk about frequency in RPM. Typically, a quick power pull acceleration is a short event. So even if it's high frequency, it happens over a shorter period of time. But if you're looking at something where you're on power or you're on peak torque, we do a lot of work with endurance racing teams. And when the endurance teams are spending a lot of time on power, that's typically where we see the damper, designed to work the most efficiently. And that's what's going to generate a lot of heat. And the challenges with that are making the damper work as efficiently as possible in that window, but then also making it have the right thermal transfer so that way you're not going to overheat the part. So that way we can have a damper that's going to last, duration of an endurance race. Similar to, we partnered with, most notably GM on the Corvette racing teams, and also on the LMDH program with Cadillac Racing.
So you're eagerly watching to see the outcome of the 24 Hours of Le Mans?
Yes, there's some great racing during those. It's a long event, but there's a lot of really great battles, and they can happen, throughout the whole event. So another application that we like another one that we talk about too, like with diesel and the sled pulling, that's a lot of like you mentioned, dwelling on peak torque, especially with the inline six engines. They really get wound up around peak torque. So I mean, a lot of it just depends on the engine and the application. The ones that tend to be higher heat usually tend to be ones that are spending a lot of time into peak power, just because it's higher frequency. And usually there's a lot more aero, so there's a lot less airflow.
Because the thing is, what to me is, and we keep talking about the new thought process of how to achieve and make race cars go quicker, faster, is the acceptable, I guess you might say, level, the peak levels that you're trying to address. And everybody wants to know, well, why is this important? I mean, I think, addressing how much damage can be done to a crankshaft and bearings in a relatively short period of time you know, a lot of people think, well, okay, well, you know, it can't be, it's not a big deal. You know, we're running a dragster. We're not in the thing any, you know, we're not really running it that long. But it's when you ask for it to run and over that period of harmonics. I mean, I don't think anybody can understand how much vibration damage can be done in a short period of time. Correct?
Yes, so the biggest thing with that, you know, and talking about, you know, like top fuel poles, you know, that on a good day, you know, you're looking at, you know, just a few seconds. So the biggest thing that we're looking at, you know, in that time, you know, you'd like to think of your crankshaft as being very rigid, but you know, they can move. You know, it's not uncommon to see a full degree or a degree and a half of displacement from end to end, even on an OEM performance application. Motorsports tends to be even higher than that. And if you think about it, you know, if you're doing a lot of pulls, you know, you're stressing that crankshaft, you know, possibly to the max multiple times a weekend, especially when you're getting towards the end. You know, if you're doing a lot of bracket racing and you're getting, you know, you're getting to the point where, you know, you're giving the car's giving you everything it has. That's the point where, you know, if you look at it, you know, we've had multiple people talk to us, and they, you know, they'll look at, you know, like mag particle inspections of their crankshafts after a long weekend, and you know, if they're running, you know, a situation where they don't have an adequate damper, it's just lit up with all kinds of cracks, and it's could have been a brand new crankshaft from the start. So even short duration races, you know, if you're twisting, you know, pushing 2 degrees, and even on like a V8 crank, which tends to be a little bit shorter, you can still have a buildup of damage. And then also while you're twisting, you're going to be side loading, and you know, you might even overcome your oil film, oil pressure, so you could have bearing contact, which reduces engine efficiency by adding extra friction, which increases oil temperature. So there's a lot to trying to keep the crankshaft running true for as much of the stressed events as possible.
Well, Nick, I think we got us a couple of questions here, and Amber would like to notice. I think this might be something that you could maybe address. Is they're racing prototypes, Hayabusa 1340s and 1500s engines, and will you guys have a product that will support that MC racing engine?
We don't have anything that's a direct fit. Sometimes applications that we do not have something that's a direct fit, you may be able to modify something that we have. In a case like that, it would be, we kind of get together with Aaron and the engineer team and see what's the best fit for that. And if there's not, if there's a high enough demand, it may be something that we could bring to market.
Okay. And then Jim Dowson would like to know, and it's probably, Aaron, be more of that in your line. How do you actually measure torsional vibration?
All right, so I touched on it a little bit earlier when we talked about, you know, looking at the crankshaft RPM, and typically what we do is we'll instrument the free end of the crankshaft, or the end where the damper itself is mounted, and then we'll also instrument the flywheel end of the crankshaft, and we go through and we have to have a certain number of you know, similar to like a racing tone wheel. So they're similar to like a tone wheel for catching timing, but we want to have a high resolution. So we want to have at least 4 times the number of, let's say we shoot for about 4 times the number of cylinders minimum. More is better for a clearer look. So we want to have a high resolution on the front, and that's where we get that really accurate RPM signal. So we can actually see how much the RPM changes at the nose. And then if we take that same signal from the flywheel end, typically, you know, the easiest setup would be just to have, you know, a threaded hole in a bracket, or possibly through a bell housing, so we can read directly off flywheel teeth. And then we can actually use that for the RPM reference signal. So because the flywheels can be a much more stable RPM. And then what we do is we take that RPM data, and we can run it through what we call a fast Fourier transform, And that's what will give us basically a time-stamped angular displacement between the two based on differing RPMs. And then that'll tell us how much it's twisting from end to end. And then if we have enough information on the crankshaft, typically, we can work with 3D models, or even if we have diameters of the different mains and pins, we can look at how much that crankshaft is getting stressed based on that displacement. And most published materials have a vibration stress limit, so we can tell you an idea of how much percentage of the engine are you of the crankshaft strength are you using when it's displacing like that. A lot of times we work on if we work with OEM back performance teams, we can have access to that information. We can even simulate some of that ahead of time and then verify it with the measurements. But the biggest thing is getting really high resolution RPM signal and then feeding that through our test equipment. We use equipment out of Germany called by a company called Rotec. And it's it's one that a lot of people in the industry use. And that's what does the fast Fourier transform. And we can do, millions of readings per second if we have the resolution.
You keep referencing, crankshaft and flywheel and bell housing. Does anything as far as the drivetrain affect you guys on the other end? I mean, if you got a bad rear gear, transmission, anything like that, how much can all that also challenge the dampener at the front?
So it's a good, a lot of it has to do with how well the engine is isolated from the rest of the driveline. Typically, a lot of racing applications will have either a really stiff sprung hub in the clutch system, or potentially even solid disc clutches, especially on like multi-disc clutches. And in those situations, you can have some vibration feedback into the engine, especially if you have a harsh event that's going on further down. Typically, if you think about a normal road going car, a lot of times dual mass flywheels are really popular right now, especially on like DCT style transmissions, where it's basically like an automated manual. That they even use similar to a dual mass flywheel system, and that isolates the engine from the driveline. But in racing applications, that kind of makes the feel of the system, for lack of a better term, it makes the feedback a little numb, because there's that little bit of disconnection with the compliance. So a lot of times if you go to a solid mass flywheel, you can have some of that feedback into your system, and that's where it would be similar to like misfires and stuff like that, where they can have an effect on vibration, where they actually raise the overall level of the vibration of the engine.
So I just want to close this out from my own mind here. How about the mounting of the engine itself? Solid mounted, versus, having, flexible or a little bit of movement, like with one of the engine mounts or something like that. Does that also factor into what, series of dampener that might need to be used?
So the mounting itself, I would say, doesn't actually affect the engines, other than the physical limits of the material that you're bolting to. But what it does, what a good damper, or what an upgraded damper will give you, is it'll actually reduce the amount of vibration from the engine outward to your chassis. I've had a few project vehicles of my own that I've worked on that either were too high a durometer isolation, or maybe full solid if it's a unique application where I'm swapping in something that doesn't necessarily fit very well. And that's where putting something, putting an upgraded damper on there, like the Fluidampr, if you're reducing all the vibrations that are transmitted from the engine to the chassis, the better. The Fluidampr with the broadband vibration damping actually it reduces more than just the engine firing. It reduces all the auxiliary vibrations that you get from different components on the engine. And that's where you see an overall reduction of chassis vibration with solid or really rigid mounting or hydrometer mounting.
And Nick, hopefully you saw that Amber replied to your answer and said that she really appreciated it, and she's definitely interested in discussing it further, and said, are you familiar with Radical Racing and or Wolf Racing? And we just got one. This came up from Tom, and Tom wants to know that how does torsional vibration differ between engine configurations, V8 versus 6-cylinder, gas versus diesel?
So the biggest difference between the V8 and the V6 as far as vibrations go, typically, well, the cylinder count. So you have different numbers of your reciprocating masses. So like the reciprocating parts of your connecting rods and your wrist pins and your pistons. Those are going to act differently because there's different counts of them. So a 4-stroke V8, half of those cylinders fire every rotation. So you're going to have 4 power pulses, which we call vibration orders. So a 4th order is going to be predominant when you're on power with a V8 application. And then in a 6-cylinder, you're going to have the three cylinders firing. So your 3rd order, or 3 power pulses. Inline 6s tend to have also, because of the longer crankshaft layout and the way that they're spaced, typically 120 degrees between counterweight throws. They also have a 4.5 order that has to do with that 120 degree spacing and the inline configuration. So the half orders are a little tricky to wrap their head around, but V8s also have a similar contribution from a 2.5 order. So basically, knowing the cylinder configuration of the engine helps to define one, where those vibration pulses are going to happen, what RPM and what frequency. And then gas versus diesel. Typically, diesel applications have a lot heavier pistons and connecting rods and rotating assemblies, so they tend to have a little bit more harsh vibration. So the twist is a little bit higher because you have more mass that you're accelerating from stop to full speed and then back. So that causes more twisting of the crankshaft with heavier rotating assemblies. And also higher cylinder pressures. So basically, if you were to look at it like a bell, a gas engine, you're not striking the bell quite as hard, so it doesn't ring out as much. Where a diesel engine, if you're striking that bell extremely hard, it's going to ring out a lot more if you don't have enough damping.
You guys sound like you got your hands full. I can tell you that right now. So how do you keep up with all the changes across the industry, Nick? I mean, is that an ongoing every day, having to get on the computer and see what's going on in different racing associations, or do they reach out to you and let you know that we're getting ready to make a engine displacement, change? I mean, how does that work, especially with, people who build customer engines versus people who build spec engines for series, that we see, just like with the Craftsman Truck Series, for example?
Yeah, so it's pretty much a daily thing. We get requests for different engines. There's so many different platforms and manufacturers, so it's a little tough to keep up with them all, but we kind of see which ones we're getting the most requests for. If it's one that is very popular, that has a high demand, it may get a little bit further ahead with production if it's something we do. As far as some of the one-off things, I know we had mentioned about adapting or modifying one of our current dampers that would fit in that spec, and that would be it would discuss with Aaron and say, okay, this is the engine, this is their power, the number of cylinders. We kind of feed Aaron X amount of information, and then he'll come back and say, okay, this may work if they can, if it's the right belt configuration, backspacing, and sometimes an adapter or something may have to be made. And it's, it's kind of just one of those things where we try to work through it, and hopefully we can come to an answer and a product that'll work for them right then and there.
And to build on what Nick had mentioned, another thing that we do when we're going through and trying to figure out what damper might work for an application, when we get a call for an application that we don't necessarily have a catalog offering for, what we'll do is we'll gather some information from the customer. Typically people come to us because they have a problem, so we want to figure out, cylinder count. We want to figure out what RPM is causing this issue. Then I can go back and do some calculations and figure out, what possible, let's say, vibration pulses per revolution are causing, what can potentially be causing problems at that RPM. And then what I can do is back that into a frequency. And then I have some calculations, some quick calculation sheets to figure out which damper from our catalog that potentially fits that frequency for, that engine. And we can get a pretty quick estimate on something that would work for the application. And then we'll sit, we'll have a conference call. We'll talk with our customers and figure out, what do they need for belt routing, what kind of space is available. We kind of get an idea of, we'll get an estimated weight to make sure that we're not going to overload, the first main and stuff like that. And then once we get further down the road, we talk about, do people need dry sump drives? They have a special belt drive system, something like a synchronous drive or a timing drive, stuff like that.
Hypothetically, and I'm not trying to put you guys in a corner, but maybe you can answer the question of, you sound like, you do a lot of working on the phone, or, let's just say with Zoom calls or whatever. Do you ever find a need to go to a location or a customer to, be a part of the actual either running it on dyno, chassis dyno, racetrack, or anything like that?
Yes. So typically, sometimes if we're working with people that don't necessarily have full access to everything as far as the measurements for the engine, so like maybe they don't have 3D models of the rotating assembly, or they're building something that's unique, something that's a little bit older. We worked with some people that build vintage Formula engines for like open wheel race cars. And we were actually doing some pre-measurement testing on engines that pretty much don't have any vibration control devices, and measuring the crankshaft twist that was there on the original crankshafts, and then measuring it on a crankshaft that they had custom built for the application. And then, in this case, we were measuring a damper that was a pendulum style damper, similar to what's used in a lot of aircraft engines. Because that's what they could fit, and that's what they had come up with. And we measured the differences between that. And then from there, we actually were able to estimate a catalog that could potentially help further. So sometimes it is necessary, especially on a truly unique build, or even a real low volume build on something that's not, let's just say, sometimes, some cases, some of these engines are really difficult to replace, and components, at this point could potentially be replaceable on some of the vintage race cars. We have traveled out in the past and done vibration testing ahead of time to see what the engine could potentially need, and then go from there.
You brought up something that got my attention, was talking about airplane engines, and I'm sitting there thinking, and I did some research, and people always talk about, how important a dampener a balancer is. I mean, whether it's yours or, but something to take the harmonics and the peak, the levels that are so detrimental to the cranks and bearings out of that. Are there engines out there into today's world that you guys find, and you, like I said, you mentioned airplane, vintage engines. Are there engines that don't have balancers that need to have balancers? And can you do something about that? Can you design a balancer to help a crankshaft? If the engine has a crankshaft in it, can y'all help it?
The one that comes to mind right off the bat for me is the Cummins inline for the 4BT.
Okay.
That one does not have a damper, and it's a pesky one with a lot of vibrations. It's one of those things. One of our dampers will work for that application, so we are able to accommodate that engine itself.
Now, that to me, I find very remarkable to a certain degree. When you design an engine, you don't take, you should, you didn't do it, and then you got to put it on there. And I guess that's got to be some kind of satisfaction for Aaron as an engineer and your company, Nick, for being able to provide that service.
Yeah, and the biggest thing with applications like that, especially when it gets moved to let's say it's living its life in a a box truck, which I think is a very common application for the 4BT. You go to switch it to performance application. I mean, it could still be in the race. It could still be in the box truck. I've seen people race box trucks, and it's pretty cool. But the biggest thing is once you start pushing it outside of its design window, that's when you run into a situation where the engine's designed to run a nice long life at a certain power level, but even just increasing turbo pressures and ejection pressures and pushing more fuel can get into an application where you're going to start having some issues with throwing belts, or maybe you have some fasteners loosening up. And that one just happens to be a nice application where that runs a similar 45 millimeter bolt pattern as the 4BT or as the 6BT on the older engines. And then the newer engines, it's similar, still the same pattern. There are some automotive applications too that use engines that don't run dampers. A lot of times those are, once again, lower power level ones, especially if you're pulling it out of a production vehicle. Automotive engineers, if they were given free rein, I would imagine designers would design things to be the best they could. But we live in a world where cost is a really big thing, especially in the automotive industry. And sometimes you can get an engine approved without a damper. They typically tend to be, low power applications. But once you got to push more power for racing, you want to be faster. You want to, but you don't necessarily want to have you would still want to have your engine last just as long, and that's where adding a damper helps.
Well, guys, I know we're getting there kind of close to the end of our seminar, but I want to make sure, do you have anything else that's coming down the line, Nick or Aaron, that you wanted to share with the folks that before I just want to make sure I've asked enough of the right questions, but do you have any other new products? Because it sounds like you guys are on top of everything that's kind of current right at the moment, and always keeping your eyes looking forward as far as what's coming down the pike also.
Yeah, so currently our biggest release that'll be coming out, we mentioned it, we touched on it earlier, is aluminum dampers for certain applications. Steel dampers will still be number one, but in some applications we will have an aluminum offering available, as Aaron said, with different configurations on the inertia ring inside, different silicones and whatnot. But so that's our biggest, I guess, new product that's coming out. I mean, we're always releasing new applications, so it's kind of hard to just pick one. But I would say the aluminum line for certain applications is going to be the new biggest one.
Yeah, and I think
go ahead.
we got one more question here. I want to make sure I don't leave Bill out. Have you ever made a dampener for a camshaft?
Yes. So we've made some for we've made some in the past for working on the excuse me, working with Cosworth on some high revving V12 engines. So we did some camshaft dampers for those. We've for quite a few, actually, I think 3 different engines for that, in that family of engines. We've been making camshaft dampers for large agricultural engines, something like a 13.5 liter for both noise reduction and twist reduction. And then I want to say we've been making, we made a lot of them OEM for Detroit Diesel back in, the Series 60 engine days. But we've also, it's something that we've looked at and we've been exploring. We're just, kind of looking for the right application to have them be more of a catalog item outside of, OEM level applications.
Well, guys, it's been a pleasure and it's been very informative. And again, you've educated, I think, several people, including myself, because I never thought about putting a dampener on a camshaft. So that right there is one more for the history book. As far as I'm concerned, I can understand crankshafts, but at the same time, vibration does come out of a camshaft for sure. So again, it's been a pleasure. Continued success. And Francis, I think that the guys are ahead of the game once more as far as Fluidampr is concerned.
Great company. I mean, and thank you to everyone at Fluidampr. They have been, one of the earlier supporter of the ePortrait platform. We have been hosting them on this webinar series probably 2 or 3 times now. So first, this webinar has been recorded. It will be posted later on the ePortrait platform and distributed through our newsletters and our social media channel. But if you enjoyed that webinar and you would like to watch previous webinars with Fluidampr, please go to ePortrait.com. We have a full library. This is episode 340, so there's plenty of them to watch in there. So thank you very much. We also pushed Fluidamprs back on the homepage of the ePortrait platform, so please take advantage of it. As we mentioned earlier, as Jeff mentioned earlier when we launched the webinar, we never sleep, so we open 24/7, 365. So thank you very much for being with us today. We will be back next week live on Wednesday, and we're going to be talking engine management system with ECU Master. Thank you very much, and we'll see you guys next week. Thank you. Bye-bye.
Thank you, Francie.
ePortrait is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePortrait, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
ePortrait really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue DEF and Blue DEF Platinum. Put trust in your truck.
I'm Michael Cruz, owner and operator of Got Mechanic LLC. Whether we're out in the field or whether we're in the bay, me and my guys are able to actually go into parts procurement and be able to pull up these prices for our parts and use the parts matrix to actually get a profit off of these parts on the fly. Parts procurement makes it even better just with being able to get in contact with my local retailers.